Welcome, .NET friends. It's another Monday, but more importantly, you know what time it is. It's another episode of the On .NET Live show. Our mission on this show, if you're tuning in for the first time, is to empower you, the .NET community members, to achieve more. I'm your host, Scott Addie, and I'm joined by co-host Cam Soper. And our guest for today is hopefully a familiar face to many of our viewers. Believe we've talked to him before. Mr. Steve Smith. Steve, would you like to introduce yourself to the audience?
Sure. Hey, Scott. Hi, Cam. Hey, everybody watching. My name is Steve Smith. Online, I go by Ardalis, mostly because Steve Smith is a super common name. And I've been doing .NET stuff since before it was .NET, so it's been a little bit. Today, my hope is to share some nice tips and tricks on how to do better things with your data access in your .NET applications.
It sounds like a very interesting topic. I have to ask, where does the name Ardalis come from?
Ardalis was actually a character name I came up with for a paladin in a role-playing game back in the 90s. And then, we started getting online computer games like Blizzard and Diablo, stuff like that. So I started using it as an online name. And, it turns out that Smith and S. Smith and Steve Smith are very difficult names to get on various social media platforms and what have you. So I just went with Ardalis because it was almost always available. Although these days, even sometimes someone beats me to that for some reason.
So you mentioned that you've been doing .NET for a while, and as you mentioned that, and I think I might have mentioned this the last time you were on the stream. I remember going to a presentation that you did it was on the show floor, so maybe it wasn't like an official presentation, but it was at Tech Ed 2007, and you did this presentation. It was in Orlando, and you did this presentation on micro caching, right? And how you can get massive performance benefits by just caching your page output for like a second, right?
That's right. Yep. That was Speaker Idle. I was competing in Speaker Idle with a 5-minute talk.
That's right. That's what it was. And I can't remember if you won or not, but I remember that talk. I went home and changed everything about how I was doing caching because of that talk. So
awesome.
Thank you.
Yeah, that was fun. Yeah, I did end up winning that because it was just a compelling demo.
It was.
Unrelated, but to the topic for today, but can I just say I miss Tech Ed and the Speaker Idle thing that used to happen? That was amazing. I think 2014 or 2013 even may have been my first Tech Ed, but awesome event.
Yeah, Tech Ed and PDC were both great.
Totally. I see a lot of familiar faces in the audience. I see our friend Saduki. I see Code with Sean. Thank you all for joining. Why don't we jump right into the topic for today? We were going to talk about data access as it relates to specification. So let's dive right in and talk to folks about really what this is, what it means to them.
Sure. So I wanted to give a little bit of background before we jump right to the end. And so I have a talk that I gave at StirTrek, which is a regional Ohio conference in 2023. And I thought I would use that as sort of the basis for this. We're going to kind of zip through some of the slides. But it'll kind of lay a framework or a foundation for what we're talking about. So forgive me with the death by PowerPoint a little bit here at the beginning, but there's going to be a lot of demos and a lot of code also. So the idea here and with this talk was to kind of show step by step how our use of data access as .NET developers has evolved, right? And so in the beginning, you've got data, and it's usually in this kind of structured, SQL Server type of way back in the early 2000s when I started. And then later on, it might be more, JSON-y or document database, something in Cosmos DB, more modern ways of storing data. We have different options, right? We can still store it relationally. And we want to be able to just fetch the data. And StirTrek is, by the way, at a movie theater, and our movie last year was Guardians. So you'll see some Guardians of the Galaxy things as we go through here. So in the old days, if you wanted to go and fetch all the authors from a table, you'd write ADO.NET code, and it might look something like this. And so you would have to be very verbose. And in looking at this, there's actually some things wrong with this. And if we were in a live audience, I'd be polling you to ask. So if you're quick with your comments, which I can't see, maybe you can identify real fast, like what's wrong with this code. If you've written a lot of ADO.NET code, you probably know some of the things to look for. All right, ready? Okay, so we're going to keep on going. And so now if we're doing ADO.NET, we want to get something more specific, like a joined collection of things, then it can become even more verbose. So in this case, we're not just getting all the things from authors table, like select star, but we're actually going to get an author. And for every author, we're going to get their courses, right? So it's sort of a master detail type of query. And so in this case, there's a few different ways you could do this, but here I'm going and fetching all the data with one query, and then I'm going to loop over that data and kind of build up the structure inside that while loop. And so again, you can see for something that's relatively trivial to do in Entity Framework code today, before we had those types of tools, you had to write a lot of code to do this type of work. So some of the coding characteristics that we want to use to evaluate how we do data access are things like ilities, these sort of non-concrete, but things we can evaluate sort of subjectively about the code, right? And so these would be things like readability, security, performance, testability, maintainability, and these are things that I thought were important, so I chose them. But that other than that, they don't really have any significance in terms of something from the industry, right? And so I'm going to give this code a report card based on this, where 5 is the most number of stars. And so for readability, it's kind of okay. It's really verbose though. Security, it's not the most secure. It's all strings of SQL inside your code, and that can have issues. There's other things that we could do that would be much more secure. Performance, it's really about as fast as you're going to get if you're trying to get the data from the database, because it's not got any abstractions. It's not got any extra layers on it. For testability, especially unit testability, it's the worst. It's terrible. I hate it. And therefore, for maintainability, it's not great either. A lot of copy-pasted code typically happens. So my big thing is that you want to follow pain-driven development. So identify where this is causing you pain and fix that pain, right? And this will lead you to incrementally improved code. And so as we look at some of these different approaches, we're going to see that. All right, so let me pull up our first demo here. And I've got this repository. This is the .NET Data Access Tour repo that I have on my GitHub. And they'll flash the URL here in a minute. So option 1, which is just using ADO.NET, looks something like this. And it's going to go fetch all the authors. And really all the demos are going to look the same. So we're not necessarily going to run them every time, but just running ADO.NET to get all the authors looks like this. And you can see, look, there's some authors. All right, so the API endpoint is working. Okay, so now let's change this up and make it so it's a little bit cleaner. We get a little bit more reuse, because we don't want to copy paste that code with those queries in the C# code all the time, everywhere. At least I don't like to do that. And if we're going to reuse that code, we should put it into a constant or something. But something that was super popular 20 years ago and is still popular in many organizations is to just use store procedures, right? So we could clean this up quite a bit by just using a store procedure. We don't have to change very much in ADO.NET for that to work. Now we're doing the exact same query, but we don't have all that SQL inside of the code. And whether it's doing it for one or doing it with the join, it's going to be the same. All the actual logic of the data query is inside of the store procedure. And so our code gets a little bit more secure because we can easily test and reuse those store procedures. We're more likely to write code that isn't going to have a SQL injection attack. Store procedures are much more hardened against that type of thing than just raw SQL. And of course, there's plenty of things we can do with our ADO.NET code to make sure we're not exposing it to SQL injection. It's just harder to make a SQL injection attack with a store procedure-based approach. Performance is still going to be super good. Testability is still going to be terrible. Maintainability is kind of on this one. It's a little bit better than it was, but not great. All right, so what else can we do? How can we make this code less, right? Because there's still just a ton of code from an ADO.NET. And so one of the things we can use is a library. Back in the old days, there was a enterprise, what was it called? What was it called? Something application block. There was a application block for data access. It was called the data access application block. That's what I was missing. So the DAAB. And it was some extension methods, some static methods that you could use. I don't even think they were extension methods. It was before extension methods exist. So static methods you could use to quickly get a data reader or a data table. These days I would use Dapper, right? And so Dapper, many of you are familiar with, super fast, super lightweight, micro ORM that you can use SQL with directly, but it adds mapping to it. And it makes it much easier for you to run these queries if you're okay with having the SQL inside your code. And so this is what that equivalent code would look like. I'm putting both of those previous examples on one slide. So this one here at the top is select star from authors, and on the bottom it's the same one with the join to get all of the courses. And so you can see it's much more compact, right? There's not nearly as much code in there. All right, so let's look at our report card for yeah, okay. So here it is with store procedures, just as a comparison. So the only thing that's changing here is here's the query and here's the store proc. And then this is sort of a report card for Dapper. It's much more readable because it's much shorter. There's not as much to copy paste. It is generally more secure by default, still very fast, still not very testable from a unit testability standpoint. And maintainability is about the same. All right. Now with SQL, when you're trying to do all of your data access using direct SQL, you're going to have at some point to deal with updates. And so if you're going to use updates, you're going to have to write your own update statements. And so you're going to say update author, set the name to this, where ID is that. And this is great if you know the only thing that people are ever going to change is the name. But what if your entities have a lot of different columns, right? A lot of different properties, and you don't know which one's necessarily changed. Well, now you've got to figure out a way to implement some kind of change tracking, or you just have to be okay with the fact that every time someone does an update, you're going to update every single column, which has a bunch of challenges with that, not the least of which is that you could be overwriting other people's changes if two people are trying to change things at the same time and you haven't put a lock on it. So one of the things that would be nice is if we could just add, oh, sorry, here's this, right, you got that, all right, is we could just add change tracking to that. And so now we can go from Dapper up to Entity Framework, which has change tracking, right? And so if you want to use EF Core for your querying, then the same code looks pretty much like this. Here's at the top, you can see I'm going to get all the authors. And then at the bottom, I'm going to get the authors with their courses. And there's no magic strings here, right? All the SQL queries have gone away because Entity Framework is going to generate those for us. And it's very good at doing that. So we don't have to be concerned that it's going to be ugly SQL or not performant SQL for something as simple as this, right? Certainly there are cases where you may want to tune the things that Entity Framework does, but for your standard data access, it generally does the job quite well. And when it comes time to do an update, instead of me having to specify exactly what changed, I can just update my entity, which Entity Framework is tracking, and then I just tell it to update and everything works fine. Okay, so quick grade on this is a little bit better readability, pretty good security now, because again, we're not having to deal with SQL injection possibilities. The performance is not as good as straight raw ADO.NET SQL calls, but it's generally fine for most purposes. The testability is a little bit better because we could wire this up to an in-memory data store. It's still not really a unit test, but it's better than having to have a database to talk to. And the maintainability is decent. All right, so let's look at another quick demo of that. We'll jump down to the Entity Framework Core version of this. And these are using controllers, but it'll work the same with endpoints. Later at the end, I'll show you some endpoint-based samples. And so here we're getting the author, including a couple of related things, and then projecting that into this data structure that we want to return. Same thing for a list, which I think was above here. Yeah, the list is super trivial. You just grab them and then map them to a DTO to return over the wire. Seeing it running over here, we back it up one. We say we're going to do EF Core. Here's my list of authors. You can see it's the exact same as we had before. All right. So now what? We've got other problems. The big problem is, what about abstractions? If we're using Entity Framework everywhere, then we don't have any abstractions. If we don't have any abstractions, we don't have any pluggability or composability. Everything is tightly coupled. We would like loose coupling to things that are out of our process, out of our system, right? Like the database. It's generally good to have loose coupling to your data store or other out-of-process dependencies. So let's add an abstraction. Now, the general name for a data access abstraction that we as an industry have agreed on is a repository. A repository is an abstraction. If it's not an abstraction, it's not a repository, right? And so you could argue, and some do, that a DB context is a repository. A DB context is not an abstraction, right? The repository abstraction is one that you own and you control. That's what gives it its power. That's why it's a useful pattern, right? Any framework you don't own and you don't control. So relying on that as a direct dependency is not using the repository pattern because it does not have an abstraction that you own. All right. So here's just a simple, easy abstraction just for authors. And so we can create a hard-coded interface that's specific to exactly what we need and just does these types of things. And so one of the things we added here is a special extra method that knows about authors and knows about the fact that it has courses, and says, get me the course with its, or get me the author with their courses. And so we had to add a method to do that. And every time we come up with another custom thing we need for this data store, we're going to have to do that again. We're going to have to add another method and add another method. And so we'll talk more about that in a second. But when it comes time to work with the repository, it's pretty simple. We're going to do the same work that we were doing before with Entity Framework, but or whichever other means we wanted, right? We could do this with ADO.NET too if we wanted. It's abstracted from how we do it. And we're going to put that logic inside of the repository implementation. And then our code that's in our controller is going to use an interface and some dependency injection. All right, so here is the implementation. And we can just put that EF code now inside of that implementation. And this gives us two big benefits. The first benefit is modularity. The second one is testability. All right, but we still have some pain that we're dealing with here. The biggest one is that we have interface per entity, which means if you have a large system with dozens of entities, you're going to have dozens of these repository abstractions. And every one of those needs an implementation. And every time we add some custom way to query something, we have to add another method. Now, at this point, I would say, hey, show me raise of hands if this describes something that you've experienced, and a whole lot of hands are going to go up because people have felt this pain with repository. A lot of people have felt this pain and concluded that repositories are terrible, we're never doing that again, and moving on with their life. But that's not the only option. Okay, so let's talk about our report card here. Readability-wise, we're in a pretty good place, right? The nice thing is that in our UI layer, in the controller, we're dealing with what we need, which is to get some data, and not how to get it, which is to use ADO.NET or Dapper or EF or whatever. The how is now behind the abstraction. It's in the implementation method, not in the abstraction, and it's totally decoupled now from the controller. All right, if we go look at the demo for this real quick, we see here's our authors controller. It's now using this author repository. And if we look at the namespaces here, it's not doing anything with data or entity framework or anything like that. Whereas before, over here, you can see we had to use Microsoft Entity Framework Core, or earlier on, I didn't show it, but we were using Microsoft Data SQL Client, right? So those dependencies are no longer a part of our UI layer or our controller here. Everything we're depending on is just our own code, which is much nicer and much easier to unit test. Okay, so what is something that we could do to fix the pain of making it so that every time we have a new custom query, we're going to have to write another method? Okay, and I'll let you just look at the rest of the report card to make your own conclusions there. So the obvious thing that we can do, and the thing that we've had in the box for some time now, is IQueryable, right? And so we can make the design just use IQueryable, and then we don't have to have a separate method every time. Right? A lot of folks do this with their repository implementation. It simplifies it. Now we can just have one method that is IQueryable, that's a list method, and we can tack onto that whatever we want. So now when we have some code, we just call the list method on the repository right here on this first line, and then everything else we need, we can just attach to that. Now, the problem with this is that we've gone from having the logic of how we're going to query embedded inside of our implementation of our abstraction inside the repository. We've pulled it back out and we've pushed it to the UI layer again. So now there's query logic in the UI. There might be query logic in some service at the business layer. There might be query logic in the controller. There might be query logic in our views or other places, right? It could go anywhere with IQueryable. And that's a blessing in a way, because you can make the query as customized as you want in any of those places. But more often than not, it's a curse, because you now have data access logic spread everywhere through your application. It's going to be duplicated. It's going to get out of sync. And every time you're trying to do something with UI, you're also going to be tripping over a bunch of data access logic that's stuck in there too, where it really doesn't belong. So you've got this ability with IQueryable that you could put logic anywhere in your system, but you really shouldn't. But it's really hard to avoid once you go down that path, right? So once you start down this path of just exposing IQueryable, it's going to dominate the design of your solution generally, right? So there's some issues here, mostly with maintainability, a little bit with readability, because if you just want to see what is the query that's going to get executed, it's really hard to pin that down. It might be in the repository, but some of it might also be in a service, in a controller, in a helper, in an extension method, in a view. You have no idea, right? Until someone actually says .toList or starts enumerating the result, anyone anywhere in the code could tack on some additional conditions, where clauses, selects, includes, and what have you. And that's a problem, right? So what if we want to control this a little bit better and not let it, not make it so that you can do anything you want, but we'll just clean it up and constrain it so that you have to pass in an expression, right? And so if you look at the definition of the where extension in LINQ, it's an expression of func of t comma bool. And so that's exactly what we're going to pass in. We're going to pass in an expression of func of, in this case, author comma bool, and we could make that generic later. That'll be another step. And so what does this look like if we want to use it? We're going to pass in some custom filter. Well, now we can say we're going to call this list async method, but we're going to pass in, whatever our where clause is as an expression. And so here we'll pass in, a.name equals Steve Smith. And that code might look like this. If we jump down, here's the IQueryable version. I think, let me double check. Number 7.
Steve, we have a question here that may be worth addressing.
Okay.
Our friend Phil Snable was asking about the expression of type and what that would mean if AOT was a thing you were doing in your application. Would there be compatibility issues with that?
The expression type? I don't believe so. I've never run into any trouble. I haven't done a lot of ahead of time compilation like for different operating systems or platforms, but I can't think of a reason why an expression wouldn't work fine in a cross-platform manner.
Okay.
Do you know? Is that something you've heard of?
It's not something I've looked into. I would have to dig into it, but it's a good question. With
the short answer is I don't know, but also I've never heard of that being a problem.
Yeah, with the native AOT stuff being new, I believe in .NET 8, it's not something I've run into yet. That doesn't mean much. Right. We have one more question while I have your attention, Steve. Wayne, so when you were talking about Dapper versus EF Core, performance was something you had mentioned. And with Dapper, you ranked it at 5 stars for perf. EF Core dipped down to 3 stars. I assume that is partly the change tracking that's to blame for the perf hit.
Mainly. Yeah, okay. You can certainly use EF to just do the exact same thing you're doing with Dapper and just use the database call, and it's within like a percentage point of performance on Dapper. So there's no significant reason to use Dapper over EF Core these days for the query specific stuff where you're just executing a query on the database. EF Core 8 has the basically feature compatibility with Dapper on that front, from what I understand. I've used some of it, but I haven't checked 100% of the feature set. But if you need to do an arbitrary query, not necessarily related to any particular entity, and then bring that back into an arbitrary DTO that you create, you can do that with Dapper. Obviously, that's been a feature it's had for a long time. You can do that also now today with EF Core 8, and there's almost no performance difference. They're both super fast. So yeah, the reason why it had 3 stars was because of the fact that it's got change tracking, and also when you do updates with EF, you're gonna, with EF Core with change tracking, the default way we typically use it, you're gonna go fetch that entity from the database and then update it and then save it. Whereas with Dapper, you'd probably just call the update statement, right? So you'd have 2 database calls with EF. You'd probably only use 1 database call with Dapper with raw SQL. And usually that's not going to matter for business software, but it is a difference. And obviously EF's using twice as many queries, although they're both really fast, simple queries. Does that make sense?
Yeah. Thanks for taking that question, Steve.
Yeah, no problem.
We can continue now with what you were talking through here.
Sure. So we were talking about the difference between the IQueryable versus the filter, the predicate that you could pass in. And so this is an example of passing in that predicate. So let's look at the IQueryable one last time here. So I'm confirming that option 7 is with an IQueryable list method here. And when we call that from the controller, if we do a example here, you won't get the courses back because when I just say, hey, give me this author and get it by ID async, what I didn't do, and it's hard to read, I know, in this commented code, but what I didn't do is include the related things. And I'm not using lazy loading, and you shouldn't use lazy loading in a web application because it will kill your performance in most cases. But since I'm not using lazy loading, I would have to explicitly eager load and include the related courses property, right? So when I get to right here and I say author.courses.select, that's null and it's not going to work. However, instead I can come in here and this one will work because I add this critical line where I say .include a.courses, and this one will still work because this is an IQueryable, and I can add things like .include and .select. The other thing is if author had 10 other properties besides ID naming courses, I would only be selecting the ID naming course, well, not even course, the ID and the name columns, and then whichever columns on the course table, I would only be selecting these 4 columns. Because I'm doing a .select, I'm doing this projection. And so that makes it so my query is going to be as efficient as it can be. I'm not just going to be doing select star and getting everything on that table. All right, so then looking at what's this change if we pass it a predicate, well, this expression of func of author comma bool lets me just say .where and then pass that directly in. And so what that lets me do is now be able to have this list where I'm passing in the filter instead of tacking it on later to an IQueryable, right? And so here's an example. This one's trivial because I want all of them. So I'm just saying a such that true. So that means, where true, right? So it's going to always return all of them. Now, the thing about this select here is that this list async is returning an IEnumerable of author. And so when I do this, it's not really a projection. It's just mapping. So I'm going to say map ID and name, but if it had 10 other columns, I fetched them all, right? This query right here is going to be a select star query. It's going to load the entire entity, and then I'm only going to grab the 2 things I need. So, projection and mapping is being done all in memory here, not at the database. So this has some negatives, obviously, right? Okay, so but the benefit is that we've constrained what we can do at the UI layer or at the non-data access layer, right? I can do this list async and I can pass things in here. I can't just keep tacking more things on later, right? So at this moment, when I get these authors, I know this is an in-memory collection of authors. I can pass that around anywhere else that I want in my system, and I know that it's just an in-memory collection, right? It's disconnected from the data store. Whereas when it's an iQueryable, it's not, right? It's connected to the data store, and it may or may not have been executed at some point along the line. And no developer knows anywhere whether that's the actual data or whether that's an abstraction of how to get the data until someone starts iterating. And so that's the biggest downside to iQueryable. iQueryable is great, but you don't want to let it escape your data access module, your data access layer, right? You want to use it inside that layer for all the great features it has. Just don't let it spread out all over your application. Does that make sense?
Yeah, the way I think of iQueryable is it's really the intent, and I think the risk here is you have no idea when that's being passed around, when the result set is actually materializing.
Right.
Is that the big concern?
Yep. And another concern with iQueryable is let's just jump to this one over here for a second. This line here is an iQueryable, right? And so if I had some cool little private method, like private bool, is cool, or even this is Steve, perfect, right? Is it Steve? There we go. Then I could do right here, and I could say .where, and if I said a.name equals Steve, this will work just fine. EF will parse that, and that will turn into a where clause on the database. But if I just say where is Steve, then that's perfectly fine too, and that will compile. And aside from whatever reason, this two list async isn't happy. IEnumerable author DTO can be found. Okay, whatever. But notice that this is all compiling just fine. But the problem is that won't actually execute because Entity Framework Core has no idea what to do with this private method. And so I don't like when you have code that lies to you, when it works in the compiler and then at runtime it fails because some magic doesn't work somewhere. So, if this were an actual IEnumerable or an actual list, then I can do this in-memory where is Steve all day long, and it works just fine. But as soon as this is actually an iQueryable and it's going to get sent to the database, then this blows up at runtime. And so that's obviously a negative as well. Does that make sense?
Yes.
Cool. All right. And I've somehow broke this code. It must have been returning something. There we go. All right. Okay. So let's come back to the slides for a second. We've added this filter. Obviously, it doesn't do everything, right? Right now, it's just helping us with where clauses. But we could add additional parameters to our method to do things like includes and other things as well. And so the nice thing is that we've got some encapsulation, right? We don't have everything exposed out through IQueryable. But the problem is there's still way too many interfaces and implementations. There's still a lot of LINQ logic, because a lot of the time what you're going to do with that expression of func of t comma bool is you're just going to build it with LINQ right there in the controller and then pass it in. So the only thing we've done is, instead of having it be a dot where at the end, we're going to pass in an expression into the parentheses of the list method. And so we still have data access logic in the controller. It's just we've moved it around slightly, and we've constrained it so we can't keep tacking more and more onto it. So it's better, but it's not great. And so looking at the report card, things aren't terrible here, right? I mean, it's 4 on readability. It's still good security-wise. Performance is fine. The performance is basically still the EF performance that I already described, why I'm not giving it more stars. Change tracking and updates taking multiple queries. Testability-wise, we're in a good place because we have that abstraction now. So I can plug in any type of mock, fake, whatever stub of data access class to implement that interface anytime I want to write any tests. And then maintainability, it's okay. It's great for testing, which is why it's got some stars. The bad thing is that pain I just mentioned, which is we still have tons and tons of repositories and tons of interfaces and implementations, and still lots of code that's going to be in the data access layer. So all of that is kind of like, how did we get here? What is the pain that led us here? So that I can talk about the real topic that I want to cover today, and that is specifications. So we're going to introduce specifications that are a class that represent a query. And so instead of having our query just be some string that we pass around, or some expression of func of t comma bool, which just rolls off the tongue, and assign that maybe to a local variable, or just pass it right into some method, or tack it onto the end of a repository that's giving you an IQueryable, we're going to give these things names, right? We're going to have a well-named class, and it's going to embed the query logic, including what to include and other things inside of it. And so these specifications are going to be really small, but they're going to be very reusable, right? They're going to have properties on them that will let us control the filtering, the includes, optionally the projection. We can add in support for paging and caching and other things. All that stuff that's related to this query will all go into this class, right? So we're going to leverage object-oriented design to our benefit. We're going to look at the pain that we have of our repository, and we're going to say, look, instead of breaking the open-closed principle and having to go in and do surgery on our repository and add another method every time we need another custom query, or every time we need to get authors with courses, now we need to get authors with courses and reviews or something else, right? That every one of those would require another method and another method. Our repositories would just get longer and longer and longer, right? Now we never have to write another method on our repository again, right? We give it a list, we give it a get, we have each one of those pass in a specification, and we no longer need to modify this interface. It is closed for modification, but it is open for extension because we can always write another specification, right? We can add as many different specification instances as we want, and then we pass those different instances into this interface to get the type of flexibility that we want in terms of what types of queries can we run. And that's the key thing. That's where, if you threw away repository before because it was too painful, because it had too many types and too many methods and it was just a big mess, this is the thing that fixes that.
We have a question, Steve. It was, I believe, on your previous slide, you had the concept of paging that's supported with a specification.
Yeah.
Here's a related question that I think paging could help solve this problem. How do you deal with results that are too large for a list?
Paging, yeah. You could also do async enumerable and just stream the results if you wanted to. That's even more performant. But most of the time, paging is what you want. If you're building like an API, a good idea is to build paging support into your API, either as parameters on the API itself, or more likely, if it's something you're going to use across the board, build it into headers in your API. That when the client sends you certain headers, it'll tell you which pages it wants. You can return in response headers information on what page you're on and how many total results there are. And that helps as well, so that you can, as a client, you can see, hey, give me the authors, and you get back, 50 authors. And then in a header, it says, hey, there's, 2,043 authors, and, you can get the next page at this URL. It makes it really friendly to the client to be able to interact with that page data set, assuming, again, that you're working with an API front end on top of your .NET app and your data access.
Awesome. I think that more than answers the question. Thank you.
Cool. All right, so jumping ahead, here's our specification-based repository. Here's what it would look like inside. So when we pass in the specification, right, we're going to have an IQueryable inside the repository, right? It's not going to leak out, but we are going to take advantage of it inside. And we can just add on, like if we got an include expression, then we'll add the include expression here to the query. And when we're done, we'll run the query and we'll pass in the predicate, right? And so with this example, we've got something to do includes, to get related data, get related things on other tables, as well as our where clause, right, our predicate. And so just by doing this, we write this code one time in our repository implementation, and we never have to touch it again, right? It's closed for modification. It does the job. When you want to have another custom query, what you're going to do is you're going to write a new specification class, and it's going to be like 6 lines of code, and that's it, right? You don't have to touch the repositories ever again. All right, so as far as usage, now there's basically going to be 2 lines of code every time you want to make a query that's a custom thing. Right? If you just want to get a list of all the authors, then that's still just called .list typically. But if you need to narrow it down, or if you need to customize it, then your first line is going to be to instantiate your specification, pass in whatever custom variables it needs, like in this case, the ID for a get by ID, and then call the repository to get it with the specification. Now here, I'm going to go ahead and do the mapping afterward. So I'm going to map it to a DTO after the fact. You can add that to your specification as well, so that you'll do the mapping as a projection, and you'll have a more efficient query that you'll make instead of doing it in memory. So that this is just an option that you do it this way. All right, so with a simple specification-based concrete repository, we're using author repository. We haven't gotten to generics yet. We have still a whole ton of interfaces and implementations. So let's look at what that code looks like with this V1 of a repository and specification. So this one is that's the one with expression of func, and then this one is the specification. So here's, I didn't show it yet, but this is the specification to go get an author. And the include expression here includes, their courses and their course. Right. So courses is a join table, and then course is the actual entity that has the course information on it. So we'll just put it here so you can see it, and that's it. Right. That's your whole specification. You just inherit from some base type, pass something into the constructor, and assign those properties that you need. Now you can create your own specification type, and it's pretty simple to do. I mean, this is what that looks like. This base class is just an abstract class that happens to have these 2 properties, one for the predicate, one for the INclude queryable. That's how .include works. That's the type it needs. And here's the include expression. So that's pretty trivial. It turns out this is super reusable, right? So you don't need to actually create a separate specification base class for every one of your entities that you use. We'll show you in just a second how we can make that generic and then put it in a NuGet package, and then you just use the NuGet package and go on your way. Okay.
Steve, you mentioned super reusable, and we have kind of a question that made me think of this. Can specifications be combined using like and or operators?
It depends, right? So the challenge there is that if you're doing more stuff than just the where clause, then it becomes difficult, right? What if you were passing in a .select inside your specification? This one doesn't show that support, but imagine it had a third property, which was the projection. And then you had 2 different specifications that each projected to different things, right? It'd be really difficult to combine those. And so in my library, our Dallas.specification, which we're getting to in just a second, we don't support that. And it's really a design decision, because as soon as you start supporting combining them, now you have to figure out all the different ways you could combine them. You could combine them with and you could combine them with or, and we need a not, right? And now it's like, well, I've got, and that's NOT, by the way. Now we've got a whole bunch of these little specifications that we combine together with ands and ors and other logical operators. And guess what? That's all query logic. Now you've got query logic all over your UI layer again, right? But instead of using LINQ or something that is easy for developers to read, you're using some crazy predicate builder and this specification and comma this other specification, comma not this other specification, and that's just a pain. What you want to do instead is just create a different specification for each one. If you really wanted to, you could create a composite specification, and it could take in 2 specifications in it. I wouldn't even do that. What I would do is I would just create a specification for each concrete thing you need and use that. And if there's a certain predicate that you're using all the time, everywhere, just put that into a constant or something that's inside your specifications folder or your data access layer and refer to that. And so every specification that needs that common predicate, you would just grab, common predicates dot, special customers or whatever. And that's how I would do the reuse. That keeps everything inside your data access layer, or even better, inside your domain model. Because the nice thing about these specifications is they don't know anything about, well, they don't have to. This one does, right? You can see it's using EF core. But the one we're going to get to in a second, it doesn't even know anything about the underlying ORM or data access layer. So it can live in your business code, in your domain model, and have no dependency on infrastructure concerns like EF, which is a good place to be. Long
Thanks
answer,
again.
but yeah, the answer is you kind of can, but you probably shouldn't. And so that's the short version. Okay, so here's where we are with concrete specification per entity. No generics. Things are not terrible, right? It's still as secure as it was. I think it's very readable. Performance is no different. Testability is high. Maintainability is high because we've got this reuse going now for these queries. One of the things that's terrible about LINQ generally is reuse, right? Yes, you could assign that expression of func of t comma bool to some constant and store it somewhere that all the developers agree they're going to use, but I don't see that happening anywhere. Basically, what I see in most .NET developers' solutions is a whole lot of links spread anywhere they might need it. And every time you need that link somewhere else, it's copy-paste coding all the way. Now, sometimes it gets pulled up into a data access layer, and that's great. That's better. But there still tends to be, if you're allowed to do it, if there's an IQueryable or a DB context that you can get to in a controller or in an endpoint or in the UI, they're going to write the link statements there because they can. And it's the simplest, easiest place to do it. And that's the thing that causes your code to turn into this big spaghetti monster later that's going to be difficult to maintain and difficult to test. Okay, so let's finally talk about generics. We could have done this sooner, and it would have given us some benefit, but for arbitrary reasons, I kept it till the end. And so what we're going to have is a single interface that's going to rule them all from a specification and repository standpoint. Now, we can write our own repository interface if we want, but notice this little note here at the bottom says this is from ardalis.specification. We're going to talk about that more in just a second. There is a built-in sample repository that you are welcome to just use. Unfortunately, it's probably bigger than you need because we've gotten a lot of folks over the years have said, hey, could you add this method and that method and the other method? So it has kind of a kitchen sink of methods on it. I would recommend you use your own. It's a little bit tighter and doesn't have every method that you don't need. But you can use this one and it will work just fine. Now, the interface that you're going to create is one that you own, and it's going to inherit from either our repository that's in the package or not, right? You can just create one that is strictly ones that you have and only has the methods you need. But this is what it looks like when you're going to use the one that we ship in the Ardalis specification package. Now, notice that the iRepository interface that we're looking at here, this iRepository base, is in the base specification package, the NuGet package. There are separate NuGet packages for Entity Framework 6. So these work with .NET Full Framework and EF6 and EF Core. And so if you want to have support for automatically mapping these things to EF6 or EF Core, you get that through a separate NuGet package. The base NuGet package has no dependency on any of that stuff. So it's not bringing in a dependency on an ORM or anything like that. And so it's perfectly okay to use in your domain model where you shouldn't have such dependencies. Okay, so here, what does this look like using the Ardalis specification? It would be something like this. And we've intentionally made it so that this query builder here looks just like LINQ, right? And so it's going to have .where, .include, .then include, just like you would expect. It is not actually using LINQ. We just made the interface the same because that way it's consistent and it's easy. And you can basically just copy paste your expression extension method based LINQ. You say .where, .include, .select, all that stuff you can pretty much just bring into your constructor of your specification and it will just work. We also have support for things like caching and things like paging. So, query enable cache is right here. And then you can specify the things that it should vary on. Right? Anytime you're going to start using caching, you should be thinking about what's your cache key going to look like? How are you going to compose that key so that you don't cache stuff and have it reuse a cached entry when it shouldn't. Right? When user A comes in and it caches something specific to user A, you don't want user B to see user A's cache data. Right? And so that's why you want to build your cache key And here, this is going to build that key with the name of the specification and the ID that was used. And that's enough to ensure that if someone comes in and asks for a different ID, they'll get the correct cached item, or it won't use the cache because it won't have been in the cache yet, right? Either way. All right, so the usage for this looks pretty much like I was just showing you, right? You say, I'm going to create this specification. I'm going to call repository dot method, dot single or dot list, whatever it might be. And then in this case, again, I'm going to do the copying of the DTO out here, just so it's consistent. But we can move that into the spec as well if we want. So what would that look like? If we add mapping, we're going to add another generic parameter onto the specification. So let's look at this spec again real quick. It's specification of author. That's our entity. That's the thing we're going to work with. It's also the thing we're going to return, right? We're going to expect to return either one or an enumerable or a list or whatever of that type. If we want to change the return type, we pass that in as a second generic parameter. So now we're saying we're going to return author with courses DTO. And that lets us take the query. The query is the same, but we can do a dot select in here too. And once you do this, now we're talking about doing actual projection. So that means that the database call is going to use the data inside this dot select. EF is going to use that to compose the SQL query and only get the columns that it needs and fetch the minimal amount of data required, rather than fetching everything and then splitting it out in memory. The downside to this is that now your specification knows about your DTO. And so depending on how your solution is structured and how you feel about that being there, right? If your DTO is really a web API concern and it's not something your domain model or your data access layer should know about, then you might not want this to be there. But if you're okay with it, it does have a lot of compelling benefits. And so that's why we support that too. Does that make sense?
That makes sense. And we have another question here. Fuel Snable asks, what about doing the specification as a source generator? Thoughts on that?
I have not done that. I think you can do source generators for a lot of cool stuff. So there's probably some opportunity there. It's not something that I've explored yet. I don't even think I've seen any issues or PRs on our repo for that yet. But it is certainly a worthwhile suggestion, something to think about. I haven't thought about it enough to have a better answer than that.
And then one more question. What about projecting anonymous types?
That would not be supported with this. It's not something I've generally needed with the designs I have, although I can see how it would be nice because you wouldn't have to have this defined DTO. You might be able to get away with it with dynamic, but I haven't tried that. Yeah, I don't think that's supported by default. I think you might have to do a different approach for that.
All right. That's it for questions.
Okay.
For now.
Yeah. So here's what this would look like if you're using it with the spec. So this one's going to return back the DTO directly. You don't have to do any other code. So your controller-based code is down to these two lines. And that's it. And so let's look at that code real quick. We'll jump down to this generic specification here at the bottom. And we can say, give me all the authors and map them to a DTO, and it would just look like this, right? There's no where clause because this is a spec to get all authors. Here's another option where you could just not even do the mapping. And so without the mapping, it's just specification of T. If you want to do author by ID with mapping, it would look like this. This is the one I just showed you on the slide. If you want to do it without the mapping, it would just look like this. Again, it's only got a single generic parameter in this case. And so it just has these things. Now, if you're talking about how you really want to be able to combine specifications, this could be combined with something probably, although even this caching bit might be a challenge. But maybe you could combine both of these things into the key that you would create. This one, you can't really combine, right? Because of the dot select. If you have two different dot selects that are returning two different output types, right, that's going to be difficult for you to figure out how to combine. In terms of usage now, notice the only thing we're using here are the MVC namespace and then my own project types for the DTOs and models. And if we look at the different methods, right, if I want to get an author, and again, it's going to come back as a DTO, I can use this specification here that's going to return me the all authors as DTOs spec. And I'm going to hit this, and it's going to return back a list of author DTO. Everything's in memory. So I've got an in-memory list of my DTOs here that I return. If I want to get it with their courses, it's going to look about the same. I can either do it here where I just let it do everything with a projection, or I can do it with this one where I get it back in memory and then I do the projection myself. Either one will work and give you the same result. Not really talking too much about the write operations, the post and the put. Those don't change, right? Those are still going to basically use EF. They are going to have a repository in front of them, so they're easy to test and change. But the specification doesn't really apply except on the fetch side of things. If we go to our demo here and we jump down to EF, that one. Maybe let's go to Swagger. So we'll go to Swagger. Here's our number 10 generic repo. We can say, get me authors, try it out, execute, and there it is. And if we want to get authors with courses, back to Swagger 10, I think we get one by ID, which was this one. We can try that out and say, well, ID 1, execute. And now you see we get all my courses in an array plus my name. So same functionality works in every one of these cases. The difference is just where we're putting the code and how we're organizing the code. And so the other thing that we can easily add on here is caching. So if we look at this, we're in a pretty good state, I think. From readability, we've got strongly named class names that tell us exactly what the intent of that query is. You don't have to parse SQL. You don't have to parse LINQ. You just read the name and you know what it's doing. Security is not really any change. Performance is not really any change. We're still just using EF. Testability is great. Maintainability is great because of all that reuse. If you want to add caching, you can put a cached repository in front of this really easily. And so that's what this looks like right here. This is our cached repository here, and it just implements the same interface. And what we're going to do is inside of our methods for like a list or first or default, either one, we're going to say, well, here, if the cache is enabled, we're going to generate the key, and we're going to say cache.getterCreate, and then call the underlying source repository to go get the data if it wasn't in the cache. If it was in the cache, we're just going to return the thing from the cache. And so this adds a lot of performance benefit. I think I've got the console running right here. And if we jump back into Swagger for a second and we run this query a few times, we say execute, 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 and then jump into the console, you'll see where it executes the command. And you know what? I don't think I have caching wired up. So it's going to do it every time. But if you go into program.cs and you tell it here that I want to use the caching, add cache decorator for repo, I think that's there. Generic EF repository. I think that's there. All right. Well, I can't see that it's doing checking the cache, fetching the source. So it's checking the cache. I was expecting there to be fewer of these long queries when I did that, but it looks like it's not hitting the cache for whatever reason. Maybe I didn't enable caching somewhere. Probably the last time I demoed this. So what is it? This one? Cache enabled, yeah. Or that one. Looks right. All right, I'm not going to spend time debugging it, but what you would expect to see is that when the cache is enabled and it finds it in the cache, that the second and the third time you run the query, it doesn't have to hit the database and you wouldn't execute the query. Not sure why that's not working right now, but I'll track it down later. So let's look at our overall breakdown here. And so looking at all the different options that we've talked about, the main ones that I recommend for most of my clients these days are the specification-based ones down at the bottom. And you can see that once you add caching, and thanks, Cam, for mentioning the caching demo from Tekka, that was a good setup. It has a huge performance impact because you're not even hitting the database. It's just returning what's in memory. And so your performance is going to be a 5 for that. You know, your write operations are going to have the same characteristics they had before, but most applications are, read mostly. They're 99% reads versus 1% writes at the most. And so by adding a caching layer, you have a huge impact on the performance of the system. And it's trivial to implement because once you have one of those generic cache decorators, it works across the board with all your code. You don't have to write that caching code ever again, right? You reuse it for every query by just setting up the specification to say that the cache is enabled.
So based on what I see in this scorecard, it looks like pretty much anything other than pure ADO.NET is the way to go in terms of security. I assume that's because of SQL injection attacks and things like that.
Yeah, that's the biggest thing I'm concerned with. And it was a top 10 problem on the OWASP top 10 list for security for, I don't know, 20 years from like 2000, well, whenever OWASP started up until maybe 2018 or 19 when it got bumped down. But it still exists out there. So that's the biggest concern is SQL injection attacks for sure.
Sure. I'm looking for the specific question here. Here it is. Earlier in the presentation, you were talking about code organization, and you showed a DTO at one point. Where would you recommend actually storing the DTOs in the solution?
Yeah, so that depends, right? It really depends on what you're trying to build. I would usually build, if I'm building a web API, and this is not related to that, but I wanted to show the specification sample, which I'll get to in the last 2 minutes. I would usually keep the web APIs DTOs in the web project. They are defining my contract for how clients are going to interact with my web APIs, and so I like for those to be part of that web project usually. If I own both ends of that contract, then I may pull them out into a separate library that is a contracts library that the client and the server will both use. And so that could be an option also. I don't usually like to pull them up into my domain model, my core project, or things like that. I do sometimes just out of expedience, but it's not my first choice.
Got it. Thank you for that answer. So Steve, we've got about 3 minutes remaining in the show. I wanted to give you an opportunity to wrap things up.
Perfect. So I've got a couple other links here. The first one is specification.ardalis.com. That's the documentation for the Ardalis specification NuGet package. It's not as comprehensive as I would like. It's an open source project. Pull requests are wonderful, but it will give you a good starting point. The actual Ardalis specification GitHub repo is out there, and so you can check that out and see how it all works. There is a sample folder that I wanted to point you at here in just a second, as well as the NuGet downloads here. You can see it's updated pretty regularly, and it's had 4.3 million downloads, so it's not a brand new project. Fadi Asseni is my co-author on that, and he does a great job and has done a lot of the heavy lifting on some of this stuff. The samples project uses minimal APIs, so everything is basically in this program.cs folder, and so you can really easily see how this stuff works together. And so if you just want to use a DB context in a real simple repo, right, you can just create a specification and then fetch it. If you want to do it with a filter, you'd pass in an ID like I was showing, and then it's pretty much the same thing here, and on and on. If you want to use your own custom repo that you're going to build, right, this sample 3 is a little more full featured, and so in here you can kind of see, like, I'm going to pass in my own repository that I control and have a customer spec, and here I'm going to pass in a filter, which is a parameter you could pass in. And this is all just to show what's possible. So it is very flexible, and you could build it with a lot of these things. It is used in the eShop on Web sample that you may be familiar with, not the new Aspire eShop, but the eShop on Web monolithic architecture sample. So you'll find specifications used here, and it's also used in my Ardalis clean architecture repo as well. So this is a solution template, and if you just want to spin one of these up, you'll see how specifications work. They're in core for any aggregate. There's a specification that goes with that aggregate, right? And so that's kind of how that's expected to be organized if you're using DDD. All right. And so with that, if you have any more questions about this, you can find me at ardalis.com. If you want some training or help with your team from a mentoring perspective, that's what we do at Nimble Pros. And we maintain a bunch of these types of open source projects and NuGet packages.
Awesome. Thank you very much, Steve, for that whirlwind tour. The feedback in the chat here seems to indicate people loved it. Wanted to show you this one. This was a great presentation, just in time for me. Thank you. Awesome to hear. I wanted to thank all of our viewers for tuning in yet again to the on.net live show. As a reminder, we have recordings of streams like this that have happened in the past. If you wanted to check those out, you can go out to dot.net/live. Next week on the show, we will be joined by guest Emmanuel Bartolesi. And the topic for that show will be JSON manipulation with some of the new system.text.json features that shipped in .NET 8. So we hope to see all of you again next Monday. Thanks again to our guest, Steve, today. That's it.
Thank you. Bye.